Hello,
Good morning, sir.
good morning.
आवाज आ रही है? हेलो।
Yes, sir.
Yes, sir.
अब ठीक है। Screen is visible.
Yes, sir.
Yes, sir.
So in the previous class, we study analytic function. Analytic function is the function is differentiable everywhere in the domain D. So there is the one criteria to check the function is analytic or not. That is the Cauchy-Riemann equation. So there is the necessary and sufficient condition for the function to be analytic. So all things we have studied in the first semester. So just I am going to recall what is the Cauchy-Riemann equation. In short, we say this is the CR equations. That is X. Okay. Cauchy RIE equations. So in short, we will say this is the CR equations. So this is if suppose fz is any complex function, write it this way: u of u of x y plus I means fz we write u plus iv. where u and y, u and v both are the functions of x and y. So if satisfies del u over del x equal to del v over del y, and second del u over del y equal to minus del v by del x. So in short, we will write this is ux differentiation of u with respect to x equal to differentiation of v with respect to y, and this is differentiation of u with respect to y equal to minus differentiation of v with respect to x. So these two equations are called CR equations. So suppose if CR equation not satisfied, so definitely we say that the function is not analytic. But we cannot surely say that if CR equation satisfy, so the function is analytic. So the main benefit is if this not happen, then surely we can say that the function is not analytic. Okay. Now harmonic function. What is the harmonic function? So a real valued continuous function. A real valued continuous function. Suppose this is phi. Phi is the function of xy. That has continuous second order partial derivatives. Partial derivatives. Suppose in any domain, any domain D, and also satisfies Laplace equation, and also satisfies Laplace equation. So what is the Laplace equation? Del 2 phi over del x square plus del 2 phi over del y square equal to 0. Now this phi is said to be the harmonic integral. So we can say that is said to be harmonic in D. Okay. So before going to the complex integration, first we recall the another terms we will use in the complex integration. So these are the curves in the complex plane. Okay. So suppose xt and yt, there are two continuous functions of a real values. where t lies between a and b. So now we write this is z equal to zt. This is the xt plus I times yt. So where both xt and yt are the continuous function defined in the interval, and it's a t lies between uh, a and b. Okay, so this t is the parameter which lies between a and b. Now if you start the curve x equal to t equal to a, means za za is xa plus I ya. Start from this to t equal to b, यानी कि zb. This is the xb plus I times yb. Okay. Okay. So the curve, this curve, so see, this is, suppose this is, so this is the ZA and this is ZB. So this curve is called closed. So when closed, the curve is called closed. If so, when this curve is called closed, if this is the beginning point and this is the end point. So if beginning point and end point both coincide, now we can say that this curve is the closed. So how we write the curve is closed if ZA equal to ZB. So we can say that this curve is closed. And second point, if so, you see the curve is closed means if this is closed, right? This is closed. So these are the examples of closed curve. If the curve is not closed, then it is arc. So this is the example. This curve is not closed. So this is the arc. And third point is simple. So when we say that the curve is simple, a curve C is called simple. So when we say that any curve C is simple, see, first of all, there is no intersection. Now we can say that the curve is simple. Yeah, in other words, we can say that कि पहले लिख लेते हैं simple if it does not intersect, it does not intersect itself. That is from the equation 1. From 1. 1 is the equation. This is 1. Okay. So from 1, ZT1 not equal to ZT2. Whenever T1 not equal to T2, except ZT1, not a ZT1, starting point is A. So ZA equal to ZB. So now we say that any curve C, this is called the simple. Simple means there is no intersection. Suppose this is closed. See, suppose this is the close. So what happened here? This is the beginning point. And if you start from this, so this is, and you go here again. So this is the end point. So accept these points, यानी कि ZA equal to ZB. Except this point, the curve do not intersect anywhere. Means what? There is a one-to-one correspondence. So if you defined, suppose f is the any function from A to B. So how we define the 1, 1? 1, 1 means we take the any two elements in A. So what happened if z f of A1 not equal to f of A2, means A1 not equal to A2. So similar kind happen here. The curve is simple, means there is a one-to-one correspondence. Means ZT1 not equal to Z22. We can take any arbitrary point on the curve. And if ZT1 not equal to ZT2, when T1 not equal to T2. This happen only except ZA equal to Z2. So here, right. So there is 1-to-1 correspondence. There is 1-to-1 correspondence between the points on the simple curve and okay, there is 1-1 correspondence between the points on the simple curve. These points on the simple curve and the values of the t and values of t in the interval a and b, in the interval a and b where t lies. Actually, in the starting, we assume that t lies between A and B. So there is a one-to-one correspondence between the points on the simple curve and the values of t in the interval A and B. So, okay. So next point is, suppose zt is, we write xt plus I yt, and the t varies from A to B. Okay. So zt is continuous in the interval A and B. Suppose. So what is the meaning of this one? Therefore, we can say that key xt as well as yt both are the continuous in the same interval. Uh, in the same interval, it's A to B. Okay. Suppose z is differentiable. So if z is differentiable means uh, also we can say that both x and y both are differentiable in the same interval. So there is the one term that is called the smooth. Smooth. Smooth means the curve defined by z equal to zt. This is called smooth. If zt is continuously differentiable, so what is the meaning of continuously differentiable? So in the bracket I just write here. Continuously differentiable means ZST exists and ZST is continuous. Okay. So first, continuously differentiable means suppose ZT is the any function. Okay. Now this function is differentiable. So we can write ZST, differentiation of ZT with respect to T. So ZT is differentiable. So that is the term differentiable. Continuously differentiable means this differentiable function is continuous. Okay. So now again we come to our main definition. What is the smooth? The curve defined by z equal to zt. Zt means xt plus xt plus I times yt. So this curve is called smooth. First of all, this z is continuously differentiable. And the number two, their differentiation z differentiation of zt यानी कि z is t not equal to 0. Now we say that e and where t varies from a to b. Now we say that zt is smooth. Geometrically we say that geometrically how we define, not a define, what is the meaning of this one? The meaning is you have any curve C, this has unit tangent at each of the points. The direction varies continuously where the as the direction of the curve C. So geometrically, this means that the curve C has a unit tangent. Unit tangent at each of the at each of the points. Varies continuously. Varies C. And the last term is contour. Okay. Suppose our curve is z equal to zt. Zt means xt plus I yt. So this curve is called contour. So when we say this is the contour, if it contour, if it is smooth or piecewise smooth, or in other words, that is curve consists of a finite number of smooth arcs. Okay, so the curve is called contour if it is smooth, piecewise. We can say that the curve consists of a finite number of smooth arcs. So now we say that the this is called the contour. Suppose our and always keep in the mind is C traverses in the positive direction. Positive direction means positive direction. Positive direction means counterclockwise direction. Okay. So, okay. Simply connected domain. A connected domain is called simply connected. Simply connected if every simple closed if every simple closed curve inside any domain D enclosed only points of D. Only points of D. So what is the exact meaning? Simply connected domains means, suppose if you draw the any simple close for this. Suppose at this point, this is the center. If you shrink, so this whole thing means this is the simple closed. This lies in any domain D can be shrunk to a point inside this D. Without this, the whole region, this living T. Means simply we say that there is the no hole that is the simply connected domain. Suppose you have the any A4 paper without any dot, purely blank. That is the example of simply connected domain. So just you write here, if for example, a plain sheet of paper with no holes in it is a simply connected domain. And multiply connected. A domain which is not simply connected. Which is not simply connected it's called multiply connected domain. So what are the examples of simply connected and multiply connected? So simply connected means there is no hole, there is no intersection. But multiply connected means doubly connected, triply connected. So that's all are the example of multiply connected. So we can see that this is example of simply connected. But this is, suppose the total region is D and this is the D1. So this is the example of doubly connected. Doubly connected means multiply connected. Means this is not a simply connected. So that is the multiply connected. In multiply connected, also we can classify this as the doubly connected. Similar fashion we can define that is the triply connected. So how can you define? Okay, one. Okay, triply connected means suppose this is, see, this, this. So this is the D1 and this is the D2, and whole thing is D. So this is the example of triply connected. So by these examples, that is the very clearly the difference between simply connected, doubly connected, triply connected. Means simply connected and multiply connected. Means this region, this is the whole. You cut this region. So suppose there is the one point here, and suppose you one point. This is the cut. So therefore, this is the triple, not a simply connected. But see, there is the one interesting example. This is the see, this is the simply or multiply connected. See, suppose see the both examples. If you start here, see, and goes to this one, this is this is. You see, suppose start from here and go inside. So both are the examples are simply connected. इसको ऐसा समझ सकते हो कि जैसे हम लोग डिफाइन करते हैं कि द फंक्शन इज कॉन्टिन्यूस, तो एक कॉन्टिन्यूटी का क्या डेफिनेशन होता है कि सपोज कोई हम पिक्चर एक ड्रॉ कर रहे हैं, तो पिक्चर ड्रॉ करने के लिए कुछ भी, जैसे हम एक लाइन ड्रॉ करते हैं तो ड्रॉ करते गए करते करते करते, तो बिना हाथ ऊपर उठाए, यानी कि विदाउट एनी ब्रेकिंग, कोई पिक्चर पूरा कंप्लीट के लिए तो कंटिन्यूस। या जैसे कोई एक इंसान घास काट रहा है तो बिना उसको ब्रेक किए वो कंटिन्यू करता जा रहा है, दैट इज द कंटिन्यूस। यहाँ पे क्या है कि that there is a difference between simply connected and multiply connected. You see in this example, इस एग्जाम्पल में अगर स्टार्टिंग पॉइंट यहाँ से है, so without any break, if you continue this one, so also you without any intersection you can reach at that point. So therefore this is called the simply connected. This is not a multiply connected. If suppose if this is the example, suppose this is so here in the point this is closed. Now if you write this is, and this is the, this is not simply connected. Connected. So not simply connected means this is the multiply connected. Cauchy integral theorem. Cauchy integral theorem. Suppose fz is any analytic function. Let fz be analytic and the derivative of fz यानी कि f dash z, this is continuous. Continuous in a simply connected domain D. In a simply connected domain D. So what are the assumption? कि fz is analytic and their derivative is continuous. Means fz is continuously differentiable. Okay. So fz is analytic means fz is differentiable every point inside the T. Apart from this, their derivative, यानी कि fz, this is also continuous in the domain T. So if these two things happen, so we can say that their integration is zero. Then integration over C. This is the symbol of closed. This is closed. Symbol for closed. Fz dz equal to 0. So this C is the, so we can write this is along. Along means on this curve C. C, this represent for C. Every simple and smooth as well as piecewise smooth. Yeah, not as well or piece. Okay. In the set domain D. So I have not written. So this is the statement of Cauchy integral theorem. But after sometimes, yes, some year, Gaussot see the statement of Cauchy theorem, and what we done, we removed some property of the Cauchy integral theorem, and after removal of this extra term, they are not affect to the integration of fz over any simple and smooth or piecewise smooth curve in the curve C contained in D. So what he removed? So he removed the function f dash z. This is the continuous. Okay. See, in the Cauchy integral theorem, the statement is you have two assumption. The fz is analytic and their derivative is continuous. If these two things happen, now we can say that their integration is 0 along C in the simply connected domain T. But Gaussot see that if you remove this extra thing, f dash z, this is the continuous in a simply connected domain D. So that is the fz is also analytic in a simply connected domain D. So this extra term, if you remove, so also see there is not effect in the integration of fz in the same domain D along the same curve C. So that is called the Cauchy-Gaussot theorem. So why we use these extra things? We always use Cauchy-Gaussot theorem. So the statement is Cauchy-Gaussot. So Cauchy-Gaussot theorem. We suppose fz is analytic in a simply connected domain D. Let fz be analytic in a simply connected domain D. Let fz be analytic in a simply connected domain D, then equal to 0. If fz is analytic in a simply connected domain D, then integration along the curve C, that is the 0. So that is the same along every simple smooth closed curve C in D, where C is the simple smooth closed curve in simply connected domain D. So this C. So now these are the examples. evaluate these integrals, number one, integral over c e के power and z square dz, where this c mod z equal to 1. Second example, e power z square third, tan z dz. Z cube minus 1 dz. And in this one, in the last, the region is a triangle with vertices with vertices at 0, 1 by 4 plus I by 2. Okay, so see, number one, what is the value of this one? So suppose solution number one, suppose fz, that is denoted by fz, this is e ke power sin z square. So first we see and plot the graph mod z equal to 1. So mod z equal to 1 means what? Mod z minus 0 equal to 1. So this is the center. Center is origin yani ki 0. This is. And the radius is 1. So draw the circle. Okay. Now in this region, check that this is analytic or not. So see, from the definition of analytic function, you can see that every exponential, every polynomial, all are analytic function. So fz is analytic everywhere. So since fz is analytic function in the given region, so apply by Cauchy-Goursat theorem, integral over c mod z equal to 1. This integration of fz dz means integration of fz over z is 0. Similarly, see, fz is e के power z by z square plus 9. Second is integral over c e power z by z square plus 9 e raised to power z by z square plus 9 dz, and c is mod z equal to 2. Mod z equal to 2. Okay, mod z equal to 2. See, so fz is right e power z by z square plus 9. So this is the analytic when z square plus 9 not equal to 0. यानी कि if z square plus 9 is 0, so fz is undefined. So fz is analytic except at z square equal to minus 9. यानी कि z square plus 9 not equal to 0. So z square equal to minus 9. Therefore, we can say that z equal to plus minus 3 iota. Okay. So see, so z equal to plus minus 3 iota. Plus minus 3 iota means, so the value of यानी कि z equal to either 3i या minus 3i. If you put, so at these 2 points the function is not analytic. So z equal to 2, if you plot z equal to center is what? Z equal to center is 0 and the radius is 2. So in this region, this is not uh, lies in this region. चेक कर सकते हैं कि z स्क्वायर प्लस 9, इफ दिस इज 0, डिनोमिनेटर को 0 किया तो z की वैल्यू क्या है? प्लस माइनस 3i. सो प्लस माइनस 3i, दिस इज द आउटसाइड ऑफ दिस वन. ये माइनस 3 और इधर क्या होगा? सपोज दिस इज द 0, यहाँ पे 1, तो ये क्या हो गया? 2, 3, 1, सपोज 2, तो यहाँ पे क्या होगा? 3. So this fz is analytic in this region. इस रीजन के अंदर अगर हम चेक करेंगे तो देखेंगे कि fz is analytic, undefined in this one. So here we can write fz is analytic inside mod z equal to 2. So therefore, by Cauchy-Goursat theorem, integral over c fz dz is 0. Okay, but suppose if this is given, mod z equal to 3, 4, whatever, so therefore this is not 0 because this is not analytic in the given region. Hello, hello,
Yes, sir.
Akash. Hello,
Yes, sir. Yes, sir.
hello,
Yes, sir. Yes, sir.
hello, Sanjit.
Yes, sir.
सर यस सर बोल
आवाज सुनाई नहीं दे रहा तुम्हारा।
यस सर बोलिए ना
हाँ, अब बोलो। फिर चला गया। हाँ संजीत, फिर से बोलना
यस
है।
सर
हाँ, ये समझ में आया?
हेलो
हाँ बोलो, सुनाई दे रहा है। हेलो,
यस सर हाँ
ठीक है, एक मिनट।
यस सर
लीड निकाल लिया। हेलो,
यस सर
ये आवाज क्यों ठीक से? हाँ, अब बोलो।
यस
यस
सर
सर। हाँ, अब ठीक है। तो ये समझ में आया? अगर इसी को रीजन को चेंज कर देते, z इक्वल टू 3 4 5, नाउ वी कैन से दैट कि दिस इज नॉट एनालिटिक, but in this region this is analytic. So therefore, according to the definition of Cauchy-Gaussot theorem, if this is analytic, so therefore their integration is 0. तो इसी क्वेश्चन में अगर 4 रहता तो इसका इंटीग्रेशन 0 नहीं होता है। नाउ वी विल अप्लाई द नेक्स्ट थ्योरम, Cauchy integral formula. So now you can see in the 1 2 3. So these two examples are exercise. You can try tan z को sin z by cos z. So mod z इक्वल टू 1 में चेक करो कि ये एनालिटिक है कि नहीं। अगर है तो इसका इंटीग्रेशन क्या होगा? 0। तो थर्ड का बताओ क्या होगा?
सर, जीरो जीरो होगा।
0 होगा। नेक्स्ट का थर्ड का 0 क्यों होगा? क्योंकि cos z क्या होगा? इसको हम लिख सकते हैं ना। अरे पेन क्यों नहीं चल रहा? एक मिनट, इसको लिखना है, लिख सकते हैं साइन जेड बाई कॉस जेड। तो कॉस जेड 0 कब होगा? कॉस जेड इक्वल टू 0। 0 मीन्स कि जेड इक्वल टू क्या क्या होगा? प्लस माइनस पाई बाई, प्लस माइनस 3 पाई बाई 2 एटसेट्रा, ये होगा ना। तो इसको अगर हम ड्रॉ करेंगे मॉड जेड इक्वल टू 1, यानी कि यहाँ पे तो पाई बाई 2, यानी क्या? पाई की वैल्यू 3.1 होता है ना, 14, यानी कि 1.7 कुछ ऐसे होगा। तो ये क्या होगा? दिस आर द आउटसाइड ऑफ द रीजन। इसका मतलब क्या हुआ कि दिस इज 0। उसी तरह इसको भी चेक कर लेना। ओके, एनी क्वेश्चन? हेलो,
No, sir.
नो सर।
हेलो,
यस
ओके बाय।